But some of the problems we face, of course, water and fire. This is where we should have smoke detectors and fire alarms throughout the building. We should have water detectors in places like, obviously, even underneath raised floors. And these alarms should be centrally monitored and linked together. So if there's an alarm in one part of the building, the rest of the building is notified. When we install smoke detectors, we don't just put them in a server room, but we'll also put them in ventilation ducts and other areas to try to pick up if there's any contaminants or smoke, even coming in from other areas of the building as well. We put in water detectors to pick up in the case of flooding or broken pipes. And then we, of course, if there is a fire, try to put it out. This is where we have a number of different fire suppression systems, a lot of them based on flooding, a lot of based on things like trying to then hit the fire with enough of a suppression system that it's going to quickly put it out. Now, there's a number of different handheld extinguishers we use. We have the ones used for Class A fires, common combustibles such as wood and paper. And a lot of the handheld extinguishers might be water, which is fine. We can use water on wood and paper. And of course, the intention of water is to reduce the temperature of the fire. Fire usually burns with three elements, fuel, oxygen, and temperature. Though some people put in a fourth one, the trigger. But if I have a fire that's burning, and I can remove any one of those three, I can remove the fuel by maybe like we do with forest fires, put in a fire break. I can remove the temperature through water, or I can remove the oxygen by, well, either something like a dry powder, a foam, a carbon dioxide, some type of a flooding system like that. Now, the one thing to remember, of course, when we're talking about handheld extinguishers is the first priority in any situation is always life safety. And before trying to put out a fire with a handheld extinguisher, we should sound the alarm so that people have a chance to evacuate. Because if a person tries to put out a small fire with a handheld extinguisher, but they're not successful, it could be now that people are not able to get out properly. So a handheld extinguisher, in fact, many fire departments will tell you, don't try and put it out. Just call us. It's better for you to get out of the building so we can get in there to focus on the fire than it is for you to try and put it out and maybe make things worse. But we also have Class B fires, which are liquids, oils, gasoline. And of course, on those, we would never use water. We would use something like a dry powder. We could use, in some cases, a wet chemical like we do over like deep fryers and so on. But the main thing with those, of course, is that you want to be extremely careful with like an oil-based fire so you don't spread the burning oil or, of course, through even like if I use a carbon dioxide extinguisher, we've got to be really careful with this because quite often it'll blow that hot oil around and make the fire worse. You then have a type of fire known as Class C, which is electrical fires, though in Europe they're kind of removing that designation. Electrical fires, again, don't use water, but often use like dry powder and so on as well. In many buildings, we have fire sprinklers, and fire sprinklers could either be wet pipe or dry pipe systems. A wet pipe system means we have water right up the sprinkler head, and if that sprinkler head, usually it has a little glass vial, that if it gets hot, it breaks that glass, it'll start spraying water. And of course, that problem with that type of a sprinkler system is that it can also cause damage if the pipes ever freeze, or even if the sprinkler head itself was damaged by somebody carrying an object or something and bouncing off the sprinkler head. We also have dry pipe systems where the actual sprinkler system is just filled with compressed air. And the idea behind that is that the water is held back at a certain riser point and is not then released until then a fire alarm signal is received. And the advantage of that is that then you don't have the water in the pipes to freeze, and the damage to a sprinkler head would not flood that area, for example. So between wet pipe and dry pipe, there's obviously, differences in cost. as well as, of course, a wet pipe system is going to spray water much more quickly to a certain area than a dry pipe system. But many server rooms today, we use inert gases. Now, in the old days, we used halon. Halon 1301 and halon 1211 were the two main halon products. And halon was fantastic for putting out a fire, but killed people. That's the only problem with it. And that's not the only problem. The other problem, of course, is that halon destroys the ozone layer. It's a chlorofluorocarbon. And so halon production was actually banned by the 1987 Montreal Protocol. And you will still see some buildings that may have halon extinguishers. Most of them have been removed, but today, if they have a gas-based flooding system, it's usually going to be carbon dioxide or maybe something like argon or some of the other inert gases. Now, these tend to be expensive, and of course, there is still that risk of life safety, because if I take a carbon dioxide system and I flood that entire server room to the point that the oxygen concentration is low enough not to support a fire, it could well be that it's also not high enough to support life. And if we had somebody who was injured in that server room, it could well be that they would not be able to be rescued in time. So some of the inert gases, we said carbon dioxide, there's others out there called sapphire and so on as well. We can use various fire retardants and other suppression agents as well to then try to remove the fuel or make things unburnable. We've used things like halon that mixed and bound with the oxygen molecules so they quite simply wouldn't burn. As we said, that for the most part has been now banned. Another product, fairly expensive though, was FM200. So what are some of the fire safety controls? Well, the first step in fire safety is always to prevent it. The second step would be to detect it. And the third, of course, to suppress it or respond to it, put it out. So the best thing is to do regular inspections. Look for the types of conditions that would make a fire more likely. Overloaded, frayed electrical lines, other materials lying around that shouldn't be, and so on. So regular inspections are important, and sometimes even bringing in the fire department can be a good idea. They'll give us advice then on if we have any hazards that we should certainly address. The other thing about the fire department is it helps if they are familiar with our building. If I have a UPS system, for example, in the telephone industry, we often have a room full of batteries, large lead acid batteries that are all huge, hundreds of pounds apiece. And the last thing you want a fire department doing is, if there's a fire, to walk into that room with all those batteries and maybe it's smoke filled and they can't see what's in there. If they walk in there and they turn on their hoses, you're going to have a very serious catastrophe very quickly. So it's good for the fire department to be aware of some of those risks as well. Another thing that can stop the spread of fire is walls. We have, for example, the walls around the server room should go directly from the floor right up to the true ceiling. We don't have these fake walls that there's actually a gap above them, above a false ceiling, because that could allow a fire to jump from one room to the next. It also can allow smoke and so on to also pass from one area to another. It's a good idea that if I have papers that I need to protect, they're kept in a fireproof safe. The idea behind that is that a fireproof safe operates on the principle of oxygen deprivation. So that I've got my papers inside the safe is sealed, and even if that safe is in the middle of a fire, the temperature will eventually penetrate through the walls of the safe. Inside the safe, it could get very hot, which is why things like plastics and CDs don't really always do well in a fireproof safe. They can still melt. But papers won't burn because there's no oxygen. And of course, the mistake people sometimes make after a fire is out is to go and open the safe before that heat is dissipated back out again. Which, of course, the moment they open the door of the safe, they've added the missing oxygen, and you have what we call spontaneous combustion. not a happy moment when you watch a few $1 million worth of stock certificates and bonds just burst into flame, because inside the safe might still be 900 degrees. Many of the fireproof safe manufacturers will tell you, you have a fire, leave the safe alone for 3, 4, 5 days. Just give it time to properly cool down again before you open the door. Make sure that the systems we have are maintained. We talked about handheld extinguishers, making sure they're being reviewed, but also we had a very serious fire in a server room a few years ago where they'd come to do maintenance, and when they do maintenance on the flooding system, they put in a safety key so it does not trigger the fire suppression system by mistake. But this company that had done the maintenance forgot to remove the safety key. And so when they had a fire shortly after, well, the fire suppression system never triggered on because the safety key was still in place. But regular maintenance and review of these systems, of course, is important.